Biomedical engineers are extremely important in the world today because as technology is getting more and more complicated and advancing more and more, it's extremely important to have someone who can work in an interdisciplinary team.
The BME curriculum is awesome because
you're doing something that translates and will have an eventual application.
We signed a partnership with them to develop our technology specifically for influenza vaccine.
Within BME you can find your niche because there's so many different focus areas.
That the students can look at and say, oh, this is how engineering, the type of engineering, the specific topic I'm learning about, this is what it means in the broader context of the world and what can be done with it.
I'm really well situated to pursue a leadership role in a technical aspect, I guess, within GE Healthcare.
There's always something new to find or something new to cure or something new to discover.
We are one of the few schools that has everything on one campus.
I feel that mentoring and being a good role model to them is very important because it can really affect their future decisions.
Our mission is to help people. I mean, certainly at some level, most every engineering department wants to do that, but ours is much more directly connected to that. And we sort of think about it every day, all the time.
Biomedical engineers draw on multidisciplinary expertise for solving complex medical problems using innovative technological solutions. At the University of Wisconsin-Madison, this collaborative approach begins with our signature undergraduate design course, which offers experiential learning throughout the curriculum.
I strive to create a very collaborative learning environment. I like a classroom where the students are teaching each other and the students are also teaching me. I love being in a classroom where I come out of that class having learned something from the students. That to me is a successful class. And so I like this multiple delivery mode of learning in that respect. So student to student, student to professor, professor to student, where it's a community.
As part of the BME curriculum, you have a design project every semester. And by taking on that design project, you really learn a lot about the different steps and processes involved in the design.
So this provides students with a lot of student-professor interaction in their classes. This allows students to learn about the current technology that's out there and how things work, but it also allows students to take part in cutting-edge research that's going on in labs throughout the campus.
The more that you can bring the material to the students' own lives and connect it to their lives, the more interested they are in it and then the better they learn it.
It's a low-cost spirometer. A spirometer is a tool used to diagnose pulmonary function, and currently in the US they're really expensive, and so clinicians and physicians are able to purchase them here in the US, but in developing countries it's just prohibitively expensive for them. So we're looking at sort of alternative designs using very simple materials and technology that can still provide a really functional diagnostic tool.
Our undergraduates come out of our program knowing how to do stuff because of our hands-on design sequence. So I think we really produce some of the best undergraduate engineers in the country because they know how to get in the lab and do something.
Our faculty are world-renowned. Master's and PhD students have the opportunity to study side by side with some of the leading researchers in the field today.
Well, I knew I wanted to go to med school, but even in going to med school, I knew that I wanted to do more than just prescribe drugs to treat people. So my research is finding a way to deliver proteins in hard-to-reach places in the body, whether that's a joint capsule in the knee or ischemic tissue. The idea is that once injected, the protein will be released in a sustained fashion over time to affect healing.
We have a graduate program that we call Biome. The students go out into the clinic and find clinical needs and find faculty all over campus who have the technological capability to realize their innovations.
And we have everything, right? So we have a med school, we have a vet school, we have law school, we have a research hospital, all attached. And they're all, you don't have to take a bus to get to any of them, so they're all here. You add on top of that WARF, for translational things.
Translational research involves collaborations between practicing physicians and biomedical engineering faculty who envision a commercial product at their inception.
When we won the Coulter Award, that really sort of forced us to focus our efforts, at least in an organizational way, around translational research. So Ratio has been around for several years now, and we've been developing the technology. So the idea ultimately is that you will be taking your flu vaccine, instead of getting a shot, you'll just put a painless patch on your arm for 10 minutes and take it off and you're done.
So I think that both advisors, Vanderbeek and Murphy, having entrepreneurial companies come out of our research and actually looking for ways to create novel technologies has really enhanced my education as a graduate student.
We've created a new model, not only for biomedical engineering department, but for engineering education in general.
I think it'll be interesting to see how it does evolve in the future, and whether the BME model sort of extends over into other departments and changes what a department looks like in the future.
So I'd like to leverage the teamwork and leadership skills that I've developed here at UW and beyond UW at GE.
While at Wisconsin, I've definitely grown, whether it's personally or academically. I've definitely been able to charter new territory, explore the things that I find personally interesting, whether that's in the lab with drug delivery, or in the community with serving underserved people, or in the medical school and starting organization and being a leader.
We bring together education, discovery, innovation, and entrepreneurship for treating, curing, and diagnosing diseases. It's very gratifying to have been a part of that.